Welcome back, students. This is the Q&A session 7 from the playlist of Motion in a Plane, and the topic for this session is parallelogram law of vector addition. Now, the question for this session is written on this board, and the question is two forces of magnitude 800 Newton and 600 Newton are acting on an object. The angle between the forces is 60 degree. So find the magnitude of the resultant force and the angle it is making with the larger force. Larger force means the angle which this resultant is making with 800 newtons. So the question is very easy. The only purpose of taking this question for this session was to um, emphasize on the calculation of finding the angle between the resultant and the individual forces, because this is something where I have found that many students are making the mistakes. So first thing is that this parallelogram law of vector addition is an extension of the triangle law of vector addition. Now I will be just explaining the triangle law of vector addition and how this parallelogram law of vector addition is an extension of the triangle law of vector addition. So let us consider this is an object O and two forces here are acting on this object. Say this is F1 and say this is F2. Now in the triangle law of vector addition, the two forces which are acting on an object and the resultant of those two forces are represented by the sides of a triangle. So here what I will be doing is, and second important point, in the case of this triangle law of vector addition, the head of one of the vector coincides with the tail of the another vector. So what I will be doing is, I will be constructing a vector which will be equal to this vector F2 in such a way that the tail of that vector coincides with the head of this vector, that is F1. Now this vector is let us say this is point O, this is point A, and let us say this is point B, and now I am constructing here one triangle like this. So here I am getting one triangle, that is OAB. Now here OB, this AB vector is representing this force F2, and this OA vector is representing the force F1. Now in the triangle law of vector addition, the forces, the individual forces are and the resultant are represented by the sides of a triangle in such a way that the addition of the individual forces, addition of individual forces, or you can say vectors, individual vectors, takes place in the same direction. First point. Second point, the direction of the result. Now this is the resultant. The direction of the resultant the direction of the resultant, that is this R, is opposite to the direction of addition of the individual vectors. That is here in just we will consider this triangle OAB. So this is O, this is A, and this is B. So from this figure you can see that now this is force F1, this OA is representing the force F1, this AB is representing the force F2, and OB is representing the resultant of these two forces. So here the addition of these two, that is here R vector will be equal to F1 plus F2 as per these two definitions. The addition of the individual vector will take place in the same direction. So here you can see here OA is directed in this direction as given by the head of this arrow. The direction of this vector AB is as given by this arrow. So the addition of F1 and F2 is taking place somewhat in the anti-clock, like this. Like this. So this is the direction of addition of F1 and F2, and the direction of the resultant will be opposite to the direction of addition of the individual forces. So here you can see the direction of the resultant is given as by this vector OB. So it is something like this. So you can see here that the direction of addition of the vectors of the individual vectors is opposite to the direction of the resultant. So now this is the definition of this triangle law of vectors. In the case of the parallelogram law of vectors, now this is the object O. Two forces are acting on this object as indicated in this diagram. These two forces are inclined at an angle theta, say, and so what here in this case, what I will be doing is I will be constructing a parallelogram in such a way that let us say this is O, this is A, this is B, and I'm now OAB. Let us see, this is C. Now, what I have done is I have constructed one vector which is equal to this F2, and it is represented by AB, and I have also constructed another vector, that is CB, which is equal to this this force vector, that is F1. So here I am drawing one perpendicular from this point B, and this is the point D, which is the intersection of the this perpendicular and this straight line, that is OA, which is extended up to this point D. So this is 90 degree. So here we have to find the angle made by the resultant with the larger force. So now this is the parallelogram, and in as per the parallelogram law of vector addition, the resultant is given by, how you will be calculating. See, this is F2, this is F1. So this angle is theta, because the angle of inclination between these two vectors F1 and F2 is theta. So this angle will also be theta. So this component will be equal to F2 sine theta, and this component, that is AD, this will be equal to F1 cos theta. So what I will so this OB square will be equal to BD square plus OD square. By you can use the Pythagoras theorem here, and finally you will be getting the answer as F1 square plus F2 square plus 2 F1 F2 cos theta. Similarly, let us say here we have to find the angle it is making, this resultant is making with the larger force. So let us consider this F1 as 100 Newton, 800 Newton, and this is as 600 Newton. So we have to find, let us say this angle is alpha. So what will be the value of tan alpha? Tan alpha will be equal to F2 sine theta, that is perpendicular upon base, divided by F1. So because OA is equal to F1 plus F1 cos theta, because AD is F1 cos theta. So OD will be equal to F1 plus F1 cos theta. So we will be using these two formulas in order to find the value of the resultant and the angle made by the larger force with the resultant. So I will be writing these two formulas here now. That is tan alpha is equal to F2 sine theta divided by F1 plus F1 cos theta. So here the resultant will be equal to what? F1 is equal to 800 square, so this is equal to 4 zeros plus 36 plus 2 times F1. Now cos 60 is equal to 1 by 2, so this 2 and 1 by 2 will cancel out. So I will be getting F1 into F2, which is equal to 48, 1, 2, 3, 4. So the resultant here will be equal to that is equal to 1216.55 Newton. So the magnitude of the resultant is equal to 1216.55 Newton. So this is the first part of this question. Now the second part. So I will be writing this value here. That is, the value of this resultant is equal to 1216.55 Newton. Now we have to find the tan this alpha. So tan alpha is equal to F2 sin theta. Now F2 sin theta means 600. Now sin 60 will be equal to root 3 by 2 divided by F1. This is equal to 800 plus F1 cos theta. Sorry, F2. Sorry, this is F2. Because see, this AB vector is representing F2, so this perpendicular component is equal to F2 sin theta, and this horizontal component is equal to F2 cos theta. So this will be equal to, so the tan alpha is equal to F2 sin theta divided by F1. This is F1, that is OA is equal to 800, or you can say this OA is equal to F1, and this AD will be equal to F2 cos theta. So this is F2. Now F2 is equal to almost 600 into cos 60. Cos 60 is 1 by 2. So this is equal to, if I divide this will be equal to 300. So 300 root 3 divided by 300 is 1100. So this will get cancelled out, and finally we will get 3 root 3 divided by 11. Now root 3 is equal to 1.732. So what I will do is 1.732 into 1.732 into 3 is equal to 5.196 divided by 11. So this is equal to 0.472. 0.472. So tan alpha is equal to 0.472. So alpha will be equal to tan inverse. So alpha will be equal to tan inverse 0.472, and this will be alpha will be equal to so that is equal to 25.26 degrees. 25.26 degrees. So the angle of inclination of this resultant with the bigger force will be equal to 25.26 degrees. So thank you very much for joining this session, and in the next session I will be taking up a different topic, but the chapter will remain the same, that is the motion in a plane. So till then, have a nice day. Bye.